this question in the probability portion of the Green Book is called Screwy Pirates 2. It says, having peacefully divided the loot in chapter 2, which it's an old question in the other portion of the Green Book, but it says the pirate team, imagine it starts here, okay? The pirate team goes on for more looting and expands the group to 11 pirates. So there's 11 pirates total. To protect their hard-won treasure, they gather together to put all the loot in a safe. Still being a democratic bunch, they decide that only any majority of them, more than or equal to 6, together can open the safe. So they ask a locksmith to put a certain number of locks on the safe. To access the treasure, every lock needs to be opened. Each lock can have multiple keys, but each key can only opens one lock. The locksmith can give more than one key to each pirate. What is the smallest number of locks needed, and how many keys must each pirate carry? So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 pirates, and we have some treasure. Some gold in it, whatever. Okay, so basically we need to find how many locks we need such that any 6 of them can open the treasure. So we need a lock such that any group of 5 people can't open it. So we have to find first how many groups of 5 people there are. How many ways can we choose 5 people from the 11 pirates? And each choosing of people needs to have a lock to protect against them. So we need to have one lock per choosing of 5 pirates of the 11. And I already discussed the choose function in the previous video. I think it was the last one or 2 videos ago. But choose just means, so if you have 11 choose 5, that just means how many ways can we choose 5, any order, any choosing of 5 from 11. And that is 462. So that means that there are there's 462 ways to choose any 5 people from the 11. And every single one of these groupings needs to have one lock to protect against them. Okay, so we have this many locks. Now, how many keys? So each of these locks needs to take in 6 keys, because we're saying that if we protect against any 5, then that lock can be opened once any 6 decide to open it. So that means that if we have this many locks, then if each lock takes in 6 keys, so number of keys total is 462 times 6. Okay, and that's the total number of keys we have. And then we're saying per pirate. There's 11 pirates total, so we divide that by 11, and we get 252. Okay? Now, to imagine this part in a different way, this part at least, we can say, instead of doing times 6 divided by 11, which is I know it's pretty simple, but you can also imagine, let's say I'm a pirate. How many keys do I have? Well, it's the number of groupings of 6 that I'm in. So any grouping of 5 that I'm not in is one that I can use. Any grouping of 5 pirates that I'm not in. So if there's 11 pirates, and let's say this is one grouping that has a lock made against them. So that's one of the groups that I'm not in, right? If I'm this pirate, right? How many different groupings of 5 pirates am I not in? Any grouping that I'm not in, I have a key for to open the treasure. So that means that I'm already here. So of the 10 remaining pirates, how many groups of 5 am I not in? And that's just saying how many ways can we choose 5 out of 10. And that's 10 choose 5, which equals, again, 252. So there's 2 ways to get to the same answer, whichever one you can see easier. So just to summarize this question, how many locks do we need? We need a lock for every grouping of 5 pirates, because we need to make sure that every grouping of 5 can't access it on their own. So we have to have 1 lock per grouping of 5, and there's 11 choose 5 ways to pick 5 pirates, which means 462 locks total. How many keys do we need? Well, each lock can take in 6 keys, because we're saying if 5 of them can't open it, then 6 can. So the other 6 can. So then we have to have 6 keys times 462, because that's how many keys we have total. Number of locks times number of keys per lock. And then divide that by 11 to get the total number of keys per pirate, because we have 11 pirates. That's one way to get the number of keys. The other way to get the number of keys is just saying, well, we're doing 11 choose 5, right? If I'm this pirate, how many of these groupings am I not in? This 11 choose 5, whatever grouping this is, they don't have the key for some lock. Okay? Now, how many groupings am I not included in? That means that if I'm this pirate and there's 5 of them, 5 others that we're making a lock to protect against, how many of those am I not in? Of the remaining 10 pirates, 5 of them will have a key made against them. How many of those am I not in? Well, it's just saying 10 choose 5 again. Well, not again, but 10 choose 5. And that's the same thing as getting 252 keys. And that's the solution.